Hi, we are from Group 67 consisting of Nur Ashikin, Nurul Iman, Zulaika, Nur Shahida and Muhammad Hafiz Jul. For the open-ended laboratory, we will do the S1 experiment, which is shear force and bending moment experiment. This is the sheet for task distribution. Shear force is a force acting in a direction that's parallel to a surface or cross-section of a body. Meanwhile, a bending moment is a measure of the bending effect that can occur when external force or moment is applied to a structural element. The objective of the experiment is to determine the shear force and bending moment at section XX and compare with the theoretical value.
Procedure. Experiment 1. Shear force. Hi, Hafiz here. The first experiment is about shear force. We need to conduct shear force variation at cut section due to variation of load and load position. The apparatus to measure shear force is shown. This is point A, B, D, and C. This is the cut section of XX where the shear force is measured. In case 1, the load 100 gram is placed between A and B. The value of shear force at section XX is measured. Next, the step is repeated with load 200 gram and 300 gram. In case 2, the step is repeated by placing the load at any point between B and D. In case 3, the step is repeated by placing the load at any point between D and C. After that, we need to plot a graph related to the measure shear force with position of the applied load P and graph that relate to the measure shear force with the magnitude of the applied load P.
Hi, Shahida here. So, I will show you what is the second objective of shear force experiment. Next, we need to determine the positive shear force and negative shear force. For objective 2, we use the measure shear force from the previous part and draw shear force diagram for each cases. The measure shear force will be positive or negative when the applied point load is applied at different part of the beam. Take case 1 as example. This is the shear force diagram and the measure value of shear force is shown.
Hi, Zulaika here. Going to explain shear force due to uniform distributed loading. So firstly, we need to apply at least 3 point loads where each point loads have same magnitude and same distance from each other. Then calculated the uniform load using the formula total load applied divided by distance. Next, we need to calculate the value of shear force at section XX by using this formula. And lastly, we need to compare the calculated value of shear force with the measured shear force at section XX. So for all these 3 cases, we need to do at different places.
Superposition principle. To prove superposition principle, we need to measure the shear force at section XX when independent load is applied at P1, P2, and P3. Next, we need to measure the shear force at section XX when all of the independent load is applied at the same time. Then, we apply the superposition principle, which is total shear force is equal to the summation of shear force at section XX when independent load is applied at P1, P2, and P3. Lastly, we need to discuss whether the measured and calculated value of shear force at section XX obey the superposition principle.
Hi, I'm Shahida to conduct experiment bending moment variation at cut section due to variation of loads position. First, we need to set up apparatus as shown. Point A, B, D, and C are marked on the beam, where the point D are the section XX to determine the bending moment. For bending moment, we applied 100 gram in between point A, B. Then the experiment forces data was recorded. Then we increased the load to 200 gram and 300 gram. For bending moment variation at cut section due to load position, after we complete the trial in section AB, which is case 1, then we repeat the same procedure as case 1 by replacing loads in between point BD and DC. Then, plot graph bending moment at section XX versus position of load and graph bending moment at section XX versus magnitude of the loop.
Hi, Afis here. I will explain to prove positive and negative bending moment are absolute equal value. We plot bending moment diagram of beam where load applied with distance D less than 440 mm from point P. We observe that the maximum sagging moment is equal with absolute maximum hogging moment.
Hi, back to me, Zulaika. For the experiment point of contraflexure, the setup is like this. This is point A, point B, point C, and point D. The section XX is at point D. First step is put the load W at point A. Then we put load P between point C and D. Next, we measure the distance between point C to load, and then we will get the bending moment at section XX, which is at point D. Lastly, we compare the theoretical value, which is the calculation with the experimental values.
For the experiment bending moment due to uniform distributed load, these are the setup. Point A, point D, point C, and then point D. Section XX is located at point D. After that, we will put the three same mass of load between the point B and then point D, and the distance between the load must be the same. Then, we will measure the point D to the load and we will get the bending moment. Then, we will repeat the procedure by adding one more point load with the three same load between the point B and the point D. After that, we will repeat all of the steps again, but we will change the three mass of load between the point A and point B. Lastly, we will compare the theoretical value with the experimental value.
Superposition principle, experiment 2, bending moment. For the superposition principle, first, we need to measure and calculate the bending moment at section XX when the load is applied at point 1. The distance the load is applied is shown in the figure. Next, repeat the step by changing the position of load to point 2, 3, and 4. Then, we need to measure and calculate the bending moment at section XX when 3 and 4 loads applied simultaneously. Last, use the formula of superposition principle to discuss whether the measured and calculated bending moment at section XX obey the superposition principle.